So coconut oil contains a triester with 3 identical R groups. The triester reacts with potassium hydroxide, according to that reaction there. Complete the equation by drawing the structure of the other product in this reaction in the box. So this is basically an ester. So each of these is going to break here. And that leaves me, so if I kind of carry that round here, that's going to give me my triol. So CH2OH, CHOH, and CH2OH. Name the type of compound with the formula RCOOK. So this is it's a carboxylic acid, so this would be the salt of a carboxylic acid. However, in this reaction here, it's the biological term for it, so it's a fatty acid, so it would be the salt of a fatty acid. And I think, well, on the mark scheme, either of those will be fine. So salt of a fatty acid or salt of a carboxylic acid. And the use for these is soap. You either know that or you don't. The triester in coconut oil has a relative MR of 638. In the equation shown at the start of the reaction, R represents an alkyl group that can be written like this. Deduce the value of N in that chain there. Right, okay. So let me separate R, and then we've got COO, CH2, R, COO, CH, and then RCOO, CH2. So what I want to do is, from my 638 here, I want to take that bit away. So I need to add all of that up. So I've got 1, 2, 3, 4, 5, 6 carbons, that's 72. I've got 2, 4, 6 oxygens, that's 96, and 5 hydrogens. And if I add all of that together, this comes to 173. So 3 R groups is... Let me draw that again. That's a 2. So I'm after this. I've just added that up. That is 173. I need to take that away from here. So 638 minus 173 equals 465, and that is equal to 3 R groups. So if I divide that by 3, so one R group has an MR of 155, and that R group is CH3 and then CH2Ns. So this bit here is 15. So if I take 15 off, so that leaves me with 140, and 140 is equal to CH2N. And this bit here is 14. So how many 14s do I need to make 140? I need 10 in there. Okay, so it's all about taking things away and just chipping away at it until it becomes something that you can work out. Part C, 1.45 grams sample of coconut oil is heated with potassium hydroxide until all the triester is hydrolyzed. The mixture is cooled, so we have potassium hydroxide left over, which is neutralized with hydrochloric acid. So this is a back titration. And I'm going to draw a picture with this one so that we can see exactly what is going on. So what I've done here is I've added my coconut oil, which is 1.45 grams of, I'll put C.O for coconut oil. And then what I've added to this here is 0.421 grams of potassium hydroxide. Now, this is in excess, obviously, because there's some left over. So when I've added this, what has happened is some of it has reacted with the coconut oil and some of it has been left unreacted. And it's the unreacted that then reacts in the titration with the hydrochloric acid from above. So the hydrochloric acid here is reacting with the unreacted potassium hydroxide. So let's start by working out the moles of that. So 0.1 times 15.65 times 10 to the minus 3. So that gives me 1.56 times 10 to the minus 3 moles of hydrochloric acid. So hydrochloric acid and potassium hydroxide react in a 1-to-1 ratio, which means this proportion here is the potassium hydroxide that didn't react with the coconut oil. So that's also 1. Start this again as well. So I don't know why it keeps doing that, but potassium hydroxide, 1.45 grams of the coconut oil. We titrated it here with hydrochloric acid, the 0.421 grams. So this bit here, just dividing it up so we can see what's happening. That bit reacted with the coconut oil. This bit was unreacted, which is going to react with the hydrochloric acid. So the number of moles of hydrochloric acid is 0.1 times 15.65 times 10 to the minus 3. That gives me 1.565 times 10 to the minus 3. Now this reacts with the potassium hydroxide in a 1-to-1 ratio. So this bit here is also equal to the number of moles of potassium hydroxide that didn't react with the coconut oil. Okay, now I've got the number of moles of potassium hydroxide that I added here, and I can work out the number of moles of that by mass divided by the MR, which is 56.1, and that equals 7.5 times 10 to the minus 3. So the 7.5 times 10 to the minus 3 is all of this bit here. And the 1.565 is this bit here. So the difference between these two is going to be the bit that reacted with the coconut oil. So the number of moles of potassium hydroxide that reacted with the coconut oil will be 7.5 times 10 to the minus 3 minus 1.565 times 10 to the minus 3. Now that equals 5.939 times 10 to the minus 3. So this is this bit here. That's the number of moles of potassium hydroxide that reacted with the coconut oil. But if you look here, it's a 3-to-1 ratio. So to get my number of moles of my coconut oil, which is essentially my ester, I need to divide it by 3. Okay, so number of moles of the triester is equal to 5.939 times 10 to the minus 3 divided by 3, which equals 1.98 times 10 to the minus 3. So the mass of my ester will be 1.98 times 10 to the minus 3 multiplied by the MR, which is earlier in the question. So 638, which is equal to 1.263 grams. So that's how much I've actually got. So this is my crude here. Okay, and this is the actual amount here. So to get a percentage here, the percentage by mass of this triester in my coconut oil, it's 1.263 divided by 1.45 times 100, which gives you 87.1%. Okay, D. Suggest why aqueous ethanol is a suitable solvent. So it will dissolve both the coconut oil and the potassium hydroxide. So that's what you want with these solvents. And then give a safety precaution and justify your choice. Ethanol is flammable. So because of that, we would use a water bath, or make sure we didn't use a Bunsen burner. So use a water bath because ethanol is flammable.